Our wireless bridge here uses passive PoE. It doesn't know how to handshake, so we need a device that doesn't ask questions. We need a passive PoE injector. Hi Tech enthusiasts, welcome back to Fast Cabling. So imagine you're an engineer. You've just hiked up a mountain where the remote industrial relay tower is. The wind is trying to throw you off the edge, and your job is to get a 4K video signal from this tower back to civilization. High winds, freezing nights, and AC power outlets that's 50 meters away. Running new power lines up here would cost a fortune, and we need to create a 15 kilometers link back to the main network. So today, we're going to show you how to set up a long-range network and solve the mountaintop mystery of why sometimes the most expensive gear won't power on. So let's look at the hero of our story. These are our 802.11ax outdoor wireless bridges. Don't let the size fool you. With the high gain antenna, it's designed to punch a signal through clear air for up to 15 kilometers and apparently windy mountaintops. Now usually power is the easy part, but this bridge only supports PoE, that's power over Ethernet. That means power travels through the same cable as data. But luckily we do have power outlets around, so on my first attempt, I grabbed a standard active PoE switch, the kind you use for a modern office phone or security camera. I'll use an Ethernet cable, plug it from the PoE port to our wireless bridge. Let's plug it all the way in and let's see. Nothing. The switch is on, the cable is good. So what gives? So this is the mountaintop mystery that I mentioned. The twist is that this bridge uses something called passive PoE. To understand why they failed, we have to look at how these two technology talks to each other. So on the switch, we have the active PoE. This is the smart handshaking type. When you plug in a device, the switch sends out a small voltage, checks for a specific response like a digital handshake, and only then does it send the full 48 volts. It's safe, it's smart, and it protects non-PoE devices from getting fried. But the problem is, our wireless bridge here uses passive PoE. It's the strong silence type. It doesn't know how to handshake. It just expects power the moment the cable is connected. So the active switch sent out its little hello signal, waited for a reply, and when it didn't get one, it simply gave up. It refused to send power to protect itself. So our bridge was left in the cold, literally. So we need a device that doesn't ask questions, it just sends power. We need a passive PoE injector, but not the cheap plastic ones. We need one that can survive up on the mountain. So this is our outdoor rated passive PoE injector. This little box is simple. It takes data from your router or switch on one side and power from a standard outlet on the other. It then combines them and sends them out over a single Ethernet cable to your device. And here's the technical magic. In a standard Ethernet cable, data usually flows on pairs 1 to 2 and 3 to 6. A passive PoE injector simply injects DC power onto the unused pairs. That's wires 4 to 5 and 7 to 8. It's a direct electrical connection. No handshaking, no negotiation, just pure reliable juice at a fixed voltage, usually 24 volt or 48 volt, depending on what your bridge needs. And because this one here is IP67 outdoor rating, it's sealed against moisture, dust, and the kind of wind that tries to steal your hat. So without saying, let's mount it on the board. So here's the full setup from the bottom of the mountain to the top. So at the base, we have our network video recorder and a WebSmart PoE switch. We're using a short patch cord to link them together so our NVR can display video clip through a big screen monitor. Using another Ethernet cable, connect our WebSmart PoE switch directly to our passive PoE injector. Let's connect it to the data port for the data. Using another Ethernet cable, connect the PoE port so we can send both power and data to our wireless bridge. So the injector powers the first bridge, which shoots the signal 15 kilometers up to the second bridge. That second bridge receives the signal, but it also needs power. So we are using an Ethernet cable here, connect our wireless bridge. This is a 50 meters Ethernet cable connected directly to another passive PoE injector. On the mountaintop, this plugged into a local power source that's 50 meters away from the bridge. That's why we need to use the 50 meters Ethernet cable. And finally, an Ethernet cable connect from the data port to our IP camera so we can monitor the video at our base station. Now, a quick word on installation, because on a mountaintop, water is the enemy. See these connectors? I took it out for faster installation, but when you do the setup, make sure you pull the cable through the neck and the gland, but don't hand tighten them. You need to use a wrench to really fasten the neck and the gland tightly. We want a waterproof seal. And also, don't skim on the cable. For PoE, especially over long distances, you need pure copper Ethernet cable. Avoid copper clay aluminum. It's cheaper, but it resists electricity and creates heat. In a freezing temperature, CCA can crack, so pure copper is more flexible and conductive. So now let's check out our video feed. I'm going to wave my hand here so we can see our live feed on the monitor at the base station. So this trick isn't just for wireless bridges. If you have any outdoor gear that expects passive PoE, like many UniFi access points and long-range security cameras, this same principle applies. And if you plug them into a standard access switch and they don't turn on, don't panic. You don't need a new switch. You just need a passive injector. So the next time your tag goes dark on a job site, remember the handshake. Sometimes the smartest gear just need the simplest partner. Thank you very much for joining us. If you like this deep dive into the nitty-gritty of networking, hit that like button, and I'll see you in our next video.